Today, we are going to do homopolar motor experiment. So, the materials that we need to use is magnet, battery, and copper wire.
First, we have to reshape the copper wire to loaf shape. And take the magnet and put the battery on top of the magnet. And put the copper wire.
Next, objective of our experiments. First, demonstrating how an electric current can produce a magnetic field around a conductor. Second, showing how the magnetic field generated by the current interacts with a permanent magnet field. Third, demonstrating the fundamental principles behind electric motors using minimal components, a battery, a magnet, and a wire. Theory explanation. The homopolar motor operates based on the interaction between the magnetic field created by the electric current flowing through the wire and the permanent magnetic field of the magnet.
What happened in the homopolar motor? Battery will provide the electric current. Magnet, typically a strong neodymium magnet. Wire will shape into a loop and act as the conductor.
According to the Lorentz force law, a force is exerted on a current-carrying conductor placed in a magnetic field. This force is perpendicular to both the direction of the magnetic field and the direction of the current. Next, let me explain how homopolar actually spins. We need to use right-hand palm rule. But first, for the magnet, we assume the north pole at the top, which is facing the battery, and south pole at the bottom. So, the magnetic field leaves the north pole and flows toward the south pole. Okay, let's focus on point A first. We know that the current will flow from positive terminal to negative terminal. So, the current is flowing in the negative Y direction and the magnetic field is flowing in the positive X direction. Use right-hand palm rule to determine the force where point the thumb to the direction of the current and other four fingers pointing to the direction towards magnetic field. So, we notice that the palm of hand opens out of the page. So that is the direction of the force, which means that the magnetic force is causing the motor to turn clockwise direction. At the point B, the current is still flowing in the negative Y direction, but magnetic field is flowing in negative X direction. By applying the same right-hand palm rule, the thumb points to the direction of the current and remaining four fingers points toward the magnetic field. So we know that the palm is facing into the page, so the force will be into the page. Therefore, the direction is still clockwise direction. We can say that if the north pole is facing the battery, it will rotate clockwise direction, like how we demonstrated in the previous video just now. But if the south pole is facing the battery, it will be anti-clockwise.
For the experiment explanation, when the wire is placed in contact with the battery, an electric current flows through the wire. The current flowing through the wire generates its own magnetic field, which interacts with the magnetic field of the magnet. According to the Lorentz force law, a force is exerted on a current-carrying conductor placed in a magnetic field. This force is perpendicular to both the direction of the magnetic field and the direction of the current. This perpendicular force causes the wire loop to spin around the battery and magnet. The loop keeps spinning as long as there is a continuous flow of current and a stable magnetic field.
The conclusion of a homopolar motor experiment typically demonstrates that the motor relies on the Lorentz force, where a current-carrying wire experiences a force when placed in a magnetic field. As a result, the wire rotates, illustrating the conversion of electric energy into a mechanical motion.